Hello everybody, this is how to derive the arctangent, the derivative of arctangent really quickly. So, we say y equals the arctangent of x, and we want to know the derivative, which is usually written as dy dx with respect to x, because we want to know that this x is, or we want the with respect to whatever the fuck this is usually. So, that's okay. So we're gonna figure it out for you guys, so you guys can know how to do this if you need to know. So, do this, okay? So step one is to take the tangent of both sides, because we can algebraically do that, because we're smart enough to know that we can algebraically do that, and we know that I'm telling you to do it, so you're gonna listen to me. Which is that means that these cancel out and you get x equals the tangent of y, okay? Now we're gonna use implicit differentiation because I'm telling you to, and it's probably what we need to do. So if we take implicit differentiation here, we take the inside derivative, and the inside derivative in this case would be 1 times dy over dx, because we're implicitly differentiating, because this is an implicit function. And so we're going to differentiate this side, and actually because it's x and we're taking the derivative with respect to x, we just say this goes to 1. But for the sake of you guys, I'm going to leave the tangent thing here so it's easier to see the steps. So we know that the next step is, oh my god, excuse me. So the next step is this, we're here, and tangent actually doesn't, oh my god. Okay, tangent, oh, I'm sorry. So tangent doesn't actually stay tangent. We know the derivative of tangent is secant squared, which I could derive in another video. Just leave a comment, guys. Leave a comment. I'll derive that for you. I'll derive it for you guys. I could do this too if you guys want. Okay. Next step. Let's keep it a rolling, okay? Next step is we want to then isolate dy dx, because we want to figure out what this is, because again we're trying to find the derivative, which just so happens to be this dy dx we got from implicit differentiation. So I'm going to set the dy dx equal to what happens when we multiply 1 over secant squared on both sides, which is we get 1 over secant squared on one side, and the other one cancels out. So now what we need to do is we need to find out we need to find out some more information. So we're gonna use some fucking shit we know. So the angle is y, because you know angle goes inside of tangent, and arctangent returns an angle, and so we know that y here is an angle. So we're gonna use that. We're gonna set it up. We know the Toa method. And so the Toa method shows that if we have the tangent, then we have the opposite over the adjacent. So that means that this is x over 1. The opposite would be x. So that means we have x here, and the adjacent would be 1. So we have 1 here. And then using the Pythagorean theorems, that we have the way that the two sides squared equals the hypotenuse. We square the two sides, we get x squared plus 1 over this equals the hypotenuse, so we could write that here, x squared plus 1 under the square root of the function. Okay, so we're almost there, guys. So the next thing we could recognize is that the secant squared y, sorry, not x, is the same as the cosine squared of y. So if we do, let's go move quick, guys. Get ladies and gentlemen to the. So if we go ahead and we just use the SOHCAHTOA again, we could say that this is equal to the squared version of adjacent over hypotenuse of y, which in this case the adjacent would be 1, and this thing would be x squared plus 1 in the square root, which is equal to then 1 squared over this thing squared. And obviously the square root of the square, since the square root is equal to the power of 1/2, and you just multiply powers, will cancel into 1, so you get, and then 1 to the power of anything is 1, so we have 1 over square root x plus 1. And so we know that the differential of y equals arctangent x is equal to 1 over x squared plus 1. And all we had to use was some trig substitution and implicit differentiation. So that's how you find the arctangent. Did I say trig substitution? I don't know. You just use trig oblometry. It's all blends together. It's not that hard, you know. So yeah, guys, this video gave me the bright idea to ask you guys to let me know if should we derive freaking secant next, secant squared derivative of tangent squared next. Maybe we even derive the derivative of secant itself, which is tangent secant, I think. Or I have to refresh myself. Let me know in the comments, guys. Let me know in the comments down below. Okay, this is.